Hello and be welcome to another video tutorial. My name is Pascal Dresselhaus and I'm a TwinCAD product manager, and today I'd like to show you how easy it is to get started with TwinCAD Analytics engineering, how to do a first configuration. For this I have prepared a virtual machine with TwinCAD Analytics service tool, and as you can see, my Visual Studio and also the TwinCAD Analytics project is already open. In general, TwinCAD Analytics is organized in networks, so you can have multiple networks in parallel, but you can also have things like that, where you have network in network in network, so that you can build up hierarchical levels. Today I'd like to analyze with you a tool torrent, so different tools of a milling machine. So we make a network tool monitoring. And then we have in this editor here more or less a blank screen, and so we have to fill up this with our algorithms, and therefore we have to go to the toolbox. And in the toolbox we have algorithms from, I say always from easy to complex. So you have easy things like counting something, timing analysis, how long are my machine cycles, statistics, min, max, average, productivity diagnosis, OEE, other things like bandwidth classifiers or a threshold classifier, a lot of different things. And then also more complex things like correlation functions, linear regression, or unsupervised clustering algorithm, for example, which goes in the direction of machine learning. But you can add also further algorithm to the toolbox, so you can do own algorithms via our analytics lambda functions, or you can install additional libraries like our power monitoring library or filter library, or the machine learning library is integrated, but also the TwinCAD condition monitoring library, which provides a lot of different algorithms, especially if you like to switch from the time area to the frequency area. Then you can do this with our function blocks here for magnitude spectrum, power spectrum, and all this stuff. But in this video tutorial, we like to do just easy things, that we have a good entry point for all of you. And so I take here my timing analysis as a first function, and here I like to describe the general setup of these blocks. So we have on the left hand side we have our inputs, we have in the middle we have our parameters, and on the right hand side we have the different outputs specific to the algorithm what we have choose here. Of course, this should be not all. We will add later more algorithm, but first of all we need some kind of data, and therefore we go to the target browser. We open the target browser. I will pin the target browser here in my Visual Studio now, that it will be open. We go to the TwinCAD Analytics tab, and there I add via the buttons here a message broker. And this means our data is communicated via MQTT. In this case, it is our TwinCAD Analytics logger, which is a logging component in the real-time context of my machine application. In this case, it is just a small embedded controller with a simulation of this milling machine. And then the logger is providing the data via MQTT. And I can connect to the message broker, and I read out here PLC stream where the data is in. So this is a machining center, and there it gives different categories like depot, info, milling, power monitoring, quality inspection, and other things. If we take a look to the milling part, then we have here some kind of ready flags, job flags, started, finished. We have the current of a motor, the speed of a spindle, and we have also the tool torrent here, what I already said, where we have different arrays. If the different tools are in use, there are 3 tools in this small application. As I said, it is not a realistic application. It is just an application to providing some data here for our video tutorial. And then we have also the temperatures of the different tools. First thing I think is very easy. So we can take here the Boolean if tool 1 is in use, and put it here to the input of the timing analysis via drag drop. We can set up here the parameters. I can switch the conditions here, but equal higher than 1 fits good to an Boolean, I think. And so we can go ahead with the standard value of the function here. As I said, we like to add some more blocks, then it makes more fun. So we have here the min-max average block, and I like now to add here the temperature of tool 1. And the nice thing is that we are able also to make some kind of analysis changes in this way, that you can take outputs and put it to the inputs, and we will do so now here with the threshold classifier. And then we can take, for example, the average of the temperature from tool 1, put it here as an input for the classifier, and then we can set up here the parameters, May 50, and the lower threshold is 40. And also a nice thing, especially for the observation of a tool, for example, is our section timer, and the section timer is also a classifier in the end. And so I take here the section timer. If I have already dropped one of the variables here to the configuration, I can go also to the drop down menu here and can choose my temperature again. And then I can set up here some border that I can define areas. So I can observe with the section timer areas of the temperature, how long I stay in which area. Sometimes, especially for a tool, this could be more important as the maximum temperature, which I reached in the past. So it's maybe for the lifetime observation, it's more important how long I stay in which temperature area. I can add here a lot of areas. In our case, we make it really easy. So 60, 50, 40, 30, and 20. And then this is configured. As I said, really quick to configure that, right? And if you start then the recording, then you directly see there are some informations, how long the temperature is in which area. And so you get here an inline histogram to observe this. The other functions providing also the output data. So here the timing analysis, if the tool is in use, yes or no, how often, how long it was in use, how long it was off. Then the temperature, min, max, average value, the timestamps where it was minimum and maximum. That's very nice, especially in the combination with our scope view, which I showed you as the last step. And then here the threshold classifier, everything is fine because we are under our warning level here. And as you can see, it increases here from time to time, depending on the usage of our tool 1. As I said, last step for this video tutorial is to add a reference scope. So I hope you know already our TwinCAD scope view, because this is a nice possibility to have, additionally to the numbers here at the output, a graphical representation of the data. And if we click on this button, we automatically add a scope configuration which is related to the configuration you have already did in TwinCAD Analytics. So you get here two axes in a YT chart. One axis is for the large real data types and the other axis is for the Boolean in this case. And if we click on that, we see here the scope data. We can zoom out here or zoom to our default display width. And the nice thing is that we can put it under each other here. I will hide the target browser now. And then you can take from here different outputs. And for example, the timestamp where the temperature was in a maximum for this tool. And if you put it here, then we jumped to the position automatically where it was a maximum. I think that is a very powerful tool. Also, if you think about to load not live data from a machine, especially historical data, if you take a look back to the last day, last week or whatever, then it can be very helpful to find significant values in your data streams, right? And so I hope you learned a little bit here from my video tutorial, and yeah, feel free to watch also the others which are existing in the TwinCAD product area of measurement. And yeah, I would say see you soon. Bye bye, take care.